So we will start the class now. So, hello everyone, I'm Shafali Agrawal, research scholar from IIT Madras, and this is your seventh problem solving session on the course Maintenance and Repair of Concrete Structure. So, as usual, first we'll go to the whatever you have studied in this week, and then we will go to for the question and answer session. So in this week, you might have studied about different kind of protective coating like anti-corrosive and zinc coating. After that, you might have studied about sacrificial anode cathodic protection (SSCP) system. And other thing you might have studied would be the ICCP system, impressed current cathodic protection system. Other than these things, you might have studied about electrochemical realkalization and electrochemical chloride extraction. This is the part of the protective methods for repair. And after that, you might have studied about the placement of repair material and curing. So the first thing is how the rebar can be protect how we can protect rebar using different type of techniques. First is we are coating our rebar using alkaline slurry. So we will clean the surface, clean the concrete surface, and then we will clean the rebar. After that, we will apply the alkaline slurry over the rebar, and then we will apply our repair material. So that is the first method of using alkaline slurry. After that, we have different type of anti-corrosive coatings which we can apply on the steel surface. Similar like alkaline slurry, there are different type of anti-corrosive coatings which can be applied onto the steel surface before the repair material is applied. These anti-corrosive coatings are mostly either they can be electrochemically active pigments or they can be zinc coating. uh, so what this is showing, if we are using zinc coating, when the zinc come into contact with the repair concrete, it is forming zinc oxide, and this zinc oxide will form a complete protective layer over the steel surface. So these are the different type of coating which we can apply over the steel bars. Other than that, what we can use is we can apply coating onto the concrete as well. So in this case, as you can see, they are applying coating over the concrete surface. This is zinc coating they are using, and zinc applied to the bar. Next is the we are applying different anodic system. We are using the sacrificial anode, and what is sacrificial anode? Usually it is made of zinc. In our series of all the metals, we see the metal which is below our metal. In our case, it is iron. Below iron, we will use that metal as a sacrificial anode. Okay, in that case, what will happen? The extra metal which we have added, like zinc in this case, it will start acting as anode, and our metal, that is our rebars, they will start behaving as cathode. And as we know, when corrosion take place, uh, uh, anode will be destroying and the cathode will be protected. So in this way, we are protecting our rebars. Other system is the ICCP system, impressed current cathodic protection. It's the similar kind of system as SCP. The only difference is it is a sacrificial anode, and in this case, we are applying current, and because of current application, this mesh which we have applied into our system, it will start behaving as anode, and our rebar start behaving as cathode. And other method which can be applied are the epoxy encapsulation of the reinforcing bar. Like different kind of rebars are available in market nowadays, like galvanized rebar or epoxy coated rebars, which you guys have already studied previously. So these are the various treatment protect methods. So to study about mainly the important thing is SSCP system. Why we have to study SSCP system is halo effect. So when our rebar is in contact with different type of environments, in this case our old concrete will have some chlorides and carbonates, whereas a the fresh concrete will be highly alkaline media. So both the concrete will have different potentials, which will create a potential difference at this point. And because of this potential difference, the rebar from this point will start corroding and will cause halo effect. So when we are using our sacrificial anode, what it is doing, the sacrificial anode will have potential more negative than both the environments. And we know the more the negative potential, more is the chances of it being acting as an anode. So this zinc anode, it will start behaving as anode and our rebar will be as cathode. And in this way, our system will be protected. For SSCP system, there is a short-term test name as gap test, uh, which was made in IIT Madras itself. So in this gap test, what we are doing, we are checking the efficiency of any anode material which we have received from the market. And this is the criteria for assessing the efficiency of any CP system by an ISO method. In this method, what is being done? Uh, our anodes are connecting to the rebar, and we are taking connection from. We'll take a connection from the rebar and from the anode. And in the monitoring box, they will be connected. So first, we will this is the on potential when these both are connected. Then we will switch it off. We will disconnect these two rebars and then we will calculate the potential, that is instantaneous off potential. After 24 hours, like after 24 hours, one day, we will again come and calculate the off potential, that is decay, decay. So this difference between instantaneous off and after 24 hours, it should be more than 100 millivolt. If it's satisfying this criteria, then we will say that our anode is performing in a good way. So anybody have doubt till this point? Okay. No, then we'll go forward. Next, methods for protecting our rebars are electrochemical chloride extraction method. In this method, what we are doing, we are applying current, DC power, DC current, and we are using a simple mesh temporary anode we are applying, and this is an electrolyte, and we will apply current. Because of this current, all the chlorides will start migrating from near the rebar surface to the our electrolyte. So this is the electrochemical chloride extraction method. Next method is electrochemical realkalization method. In this same procedure we are applying current and we are using some electrolyte and anode. This electrolyte will have more alkaline particles. So when we are applying current, these alkaline particles, they will start penetrating into the concrete and they will repassivate our system. So this is all about the protection methods which we are applying in our uh, for repair system. So if anybody have any doubt in any of the methods, please let me know. I'm audible to you guys, right?
Yes, ma'am.
So if there is no doubt, then we'll go forward. So next is the different placing methods. So how we are placing our repair material. First is the trowel application. For small application, what we are doing, we are just using our simple trowel and applying the repair material or mortar. Next is the dry packing. In dry packing, what we are doing, we are just applying a small formwork kind of thing, and the material is very, it's not flowable. The material is very dry, and we are just pushing it through uh, through our system. Next is the forming and pumping. A formwork is applied and concrete is pumped to the system, and all these material is compacted through the pressure only. So normally the concrete is filled from the bottom in this case, and the other part is forming and cast in place. In this case, what we are doing, we are using the formwork and then we are pouring the concrete into it. In this case, compaction is done manually. using some compactors. But in this case, compaction is done automatically due to the pressure. Next is the grouted pre-placed aggregate. In this case, what we are doing, we are using gap created aggregates and filling it completely. And after filling all the aggregates, we are pumping the mortar into it. So this is the grouted pre-placed aggregate method. Other method of shotcreting. Shotcreting is pumping the mortar onto the surface using some nozzle kind of thing. So we have two type of shotcreting: wet shotcreting and dry shotcreting. In wet shotcreting, what is happening? All the mortar, complete mortar. So, can you please mute yourself? So the complete mortar along with the water is sprayed through the surface, and this is the wet shotcreting. And in dry shotcreting, what is happening? We have two rings here. All the material which we have is the dry material only, and water is coming through the different source. So at this point, the dry mortar and the water will mix, and then we are spraying over to the surface. So this is the dry shotcreting. So these are the different placing methods which are being used. And next are the curing methods. We have different type of curing methods. We are using curing compounds, or we are ponding, we are water spraying, or different kind of curing methods are there. So this is what you might have studied in this week. So if anybody have any doubt, please let me know. If no, then we will go to the question and answer session for this class. Okay, then we will go to the question and answer session for today. So the first question is, which of the following are the benefits of gap test? So gap is galvanic anode. Hello? Sorry. Hello? So what are the benefits of gap test? Gap test is galvanic anode performance test. So first option is to evaluate the performance of commercially available galvanic anodes, to estimate the throwing power of anodes, to estimate the service life of galvanic anodes, or to help in increasing the current output. So what are the benefits of gap test? Anybody want to see? Okay. Service life of galvanic anode can be estimated. Correct. Any other option you think is correct? Estimate the throwing power of actually that thing we can't estimate through gap test, but yeah, we can evaluate the performance A and C. Okay, correct. So throwing power of anodes we can't estimate through gap test as of now. So the correct answer are A and C only. It can evaluate the performance, and it can estimate the service life of galvanic ornaments. I think you might have studied that graph. Like it will go this way, and suddenly the current will drop. The point at which this is dropping, we are telling our anodes are not working now. And through this, we are calculating the service life of our galvanic anodes. Okay, is this question clear to everyone? Okay, then we'll go to how can we calculate the option B? Okay, how can we estimate means by which method? How can we estimate the throwing power of anions? See, we cannot actually exactly estimate the throwing power of anodes. The only thing we can calculate is the current output, right? Using gap test or any method which we are doing like that ISO method also. So throwing power is mainly how much it can protect, like how much one anode can protect how much area of steel. So that thing, as of now, there is no method to calculate that thing. I hope it will come soon. Next question is cathodic protection using galvanic anodes or using impressed current techniques will regain some of the corroded steel cross section in concrete. Is it a true or a false statement? Do you think any method, any cathodic protection method can regain the cross section of the rebar? False. Okay. So once the cross-sectional area is removed, it cannot be regained. If we can say that some rust particle is being covered over the rebar, and we can say and we are telling that it is the cross-sectional area, so it's wrong. When our rebar start acting as cathode, it won't even lose its cross-section area, nor it will gain anything. So it's a false statement. Next question. In impressed current cathodic protection system, titanium is widely used as the anode material because of its high corrosion resistance and least maintenance. Based on this, select the most suitable anode material from the list given below. In ICCP system, we are using anode as a mesh over the concrete, right? A, which is zinc. See, on what basis we can select a material is we have our EMF series, right? Electrochemical series we have. So in electrochemical series, we different materials are there based on their potential. Uh, we have labeled them. The sequence is made based on their potential, like gold, platinum, and all these things. The zero potential thing is H2. All the metals which come above these H2, which have potential higher than H2, they are called as the noble metals. And all the metals which come below this H2 are called as the active metals. So whenever we have to select our anode and cathode, what we will see? What is anode? Anode will be okay. So the material, any metal which is below will be active metal. Active metal means it will corrode first. So based on that, we are choosing our anode. In our SACP system also, when we are saying that for iron, we are choosing zinc. It means zinc lies below iron in EMF series. That's why we are choosing zinc metal. And if zinc is lying below iron, means its potential is more negative. More the negative potential means more is the chance of it being oxidized, right? This equation you might have studied. Zinc converting into zinc to positive plus 2 electron. So this is a reversible equation. When the potential is more negative, means the forward reaction is more supportive. So that's why in case of iron, we are choosing zinc because zinc potential is more negative than iron. There are other metals also in between whose potential is more negative than iron, and there are metals below zinc also whose potential is more negative. But why we are choosing zinc is first reason is its potential is below iron, and second reason is zinc is more compatible with iron. And in our concrete system, which is more alkaline, according to Pube diagram, zinc will be in active state. This diagram you might have studied of zinc. So high alkaline media, zinc will be more active. So that's why we are choosing zinc in case of iron. So if in ICCP system we are using titanium, so what can be the most suitable anode material? The answer is stainless steel. I think there is some problem with question only because here also I have written anode and here also is anode. So I will check the question for one. Okay. So, but I hope you understood the concept of how we are choosing anode and cathode in any case, right? This part is clear to everyone. In this question, there is some issue with the anode and cathode thing, but this part is clear to everyone, right? Have any doubt? You can ask the question. Revti, you raised your hand. You have any doubt? We'll go to the next question then. Select the appropriate statement about electrochemical fluoride extraction, EC. It is a long-term treatment which may reduce the fluoride ion concentration in the system. It can repassivate the embedded steel. It is a destructive method. EC can increase the pH of thin layer of concrete surrounding the rebar. What do you think are the correct statements? A. Okay. Long-term treatment, reduce chloride concentration. Okay. Any other option you think is correct? Can it repassivate the steel surface?
No, ma'am.
Sure. Okay. It's a destructive method, yes or no?
No, no, ma'am.
Increase the pH. Answer is B and D actually. What wrong with A is it's not a long-term treatment method. It takes few weeks or hardly month or 2 months. So it's not a long-term treatment method as the other methods. It can reduce the chloride ion concentration, but it's not a long-term method. That's why this option is wrong. How it is repassivating the embedded steel is via the electrolyte which we are using. Uh, show you the diagram. See, in this case, what is happening? The electrolyte which we are choosing will be alkaline medium, right? So, like calcium hydroxide, if we are using, imagine we are using calcium hydroxide. So, when current is applied, what is happening? Chlorides are going towards the electrolyte and they are forming calcium chloride, and hydroxide is going towards the rebar. So that will be a complete reaction will take place, right? So hydroxide are going into the concrete and chlorides are going out of the concrete. So based on this thing, we can say that more the hydroxide will be, more will be the pH, right? Hydroxide give alkalinity to our system. So based on this method, we can say that our pH is increased and the pH nearby the steel surface will be increasing and it can repassivate the steel surface. Is it clear now? I hope it is clear how it is repassivating the steel surface. Okay, then we will go to the next question. Why calcium hydroxide is used as an electrolyte in electrochemical fluoride extraction method? We are using different kind of electrolytes. Out of that, one of the electrolyte is calcium hydroxide. Why is it being used as an electrolyte? It causes etching of concrete or it prevents etching of concrete. It reduces the acidification of electrolyte or it can help eliminate alkali silica reaction. See, okay. It prevents etching of concrete and it reduces the acidification of electrolyte. Okay. How is it reducing acidification? Because all the chlorides are being extracted from the concrete surface and lesser the chloride and more the OH are coming into the surface, into the concrete. And because of that, the acidic part of the concrete is reduced. Sorry, reduces the acidification of electrolyte. Electrolyte acidification is reduced. Okay. You know etching of concrete, right? C, correct. Some protective method, what they will do when we apply current and because of the movement of ions, the concrete surface will have some undulation or we can say etching of surface will be there. When we are using calcium hydroxide as the electrolyte, the benefit of the calcium hydroxide is it prevents this kind of etching of concrete surface. So B and C are the correct answer as you guys have already guessed. Next question. Both SACP system and ICCP system can cater the need for increase in current output if required. True or false? Can we change the current output in both cases? Alter the current output in both cases? True. Okay. Anybody else who think it's a false statement? Actually, it's a false statement because in SSAP system, what we are doing, we are just attaching our sacrificial anode to the rebar. There is no current output or input system. It's the current is going in automatic way. Like automatically, the anodes are providing current to the system. In ICCP system, we are providing current from externally. So if we want to increase the current output, we can increase the current output in case of ICCP system. But in case of SCCP system, we can't alter any current output. So that's why this statement is false. I hope it's clear to everyone, right? The advantages of SACP system over ICCP system include: once installed, SACP doesn't need continuous monitoring. SACP doesn't need external electrical unit to supply current. If corrosion rate is very high, SACP works better than ICCP or all of the above. B, doesn't need external electrical unit, correct. Other option you think is correct? Answer is both A and B. B, as you know, we are not applying any external electrical unit. The anodes is been in sacrificial, it will sacrifice itself to protect the rebar. Other thing is when we have already installed SFC anodes into the system, we don't need to continuously monitor it. However, we do need to monitor it for ourselves to check if it's working or not. But as of now, uh, if our system is idle system, then we don't need any continuous monitoring. So that's why first option is also correct option. However, when we have a highly resistive environment, if environment is very resistive, the ions from our sacrificial anodes, they won't get any place to move from the anode to the cathode to the rebar system. So in highly resistive system, we want SSCP system won't work in a good way because the ions will not be able to move from one place to another. The movement of ions will be stopped. So that's why we are saying that ICCP is a better option in case of highly resistive environment. Okay. Then we'll go to the next question.
Ma'am,
Yes.
ma'am, for point anodes, we have to give singular monitoring box for particular anode, ma'am.
Yeah. Monitoring box is there, but
Monitoring box is there, but
huh,
if we are using point anode, then how much monitoring box we have to install there, ma'am?
how many monitoring box we have to install?
Because after pouring means if we do micro or if we do PMM over it, that anode is working or not,
How we
without
can check?
monitoring
Hmm.
box we are unable to get it, ma'am.
Yeah.
And
Actually, one
there
of
are
my
two types
senior
of
is working on this thing only. Our research topic is same thing, how we can monitor our if our anodes are working or not.
there
So
are two types of anode, ma'am. Out of them, point anode is there, and another type of anodes are there. They are connecting with each other with a wire.
yeah, tie wire we are
Uh,
using.
yeah, if we are using that another one, then by single monitoring box we are able to know that all the anodes are working or not, ma'am. But for point anode, the thing is little
Yeah,
else.
for that kind of anodes only, she's currently working. She's trying to get a new non-destructive method which can help in monitor our SACP system. So as of now, in my knowledge, there is no method to monitor
Monitoring,
and
yeah.
yeah.
And
Or
I have one doubt, one more doubt, ma'am.
hmm,
Uh, Regarding shortcreting, ma'am.
yes,
If we, because there is little denseness comparatively regarding shortcreting, ma'am.
yes.
So how, if the reinforcement get corroded, then
Hmm.
its expansion in volume will uh, let us know after long time, ma'am.
In you are saying that after short creating, if rebar
If
is
we do
corroding,
shortcreting,
hmm,
then that shortcreting is little bit porous, na, ma'am,
yeah, it will be
compared to
porous.
if we relate it with micro or PMMM, it's
Hmm.
a little bit porous,
Yeah.
because from 1 meter by pressure we are doing that shortcreting, but it's little bit not that much denseness, ma'am.
Hmm.
So is it beneficial to do shortcreting
See,
or
all these methods they have their own applications. We can say, right? So short creating, I don't think we do short creating in case where our rebar is visible. Mostly short creating is for smaller area, right? Like
no,
walls or
ma'am? But
something. Huh?
like in tunnel and or the
Tunnel.
retaining wall,
Hmm.
we are doing it, no, ma'am.
Yeah, we
Because from 1 meter we have to do it, ma'am. If the small area is there, we are unable to do it.
small area. I means small exposed area. Depth should it should not be too much depth, na? Like if our cover depth, complete cover depth is there, as far as I know, we don't use short creating if our depth is too much.
Okay, ma'am.
So
Okay, ma'am.
okay.
Okay, thank you very much, ma'am.
Somebody was asking something. Sorry, I didn't. Rachna, you were raising your hand. You have any doubt?
No, ma'am. I was actually voice is not audible. Now it is audible.
Oh, okay, okay. So next question. In electrochemical realkalization, electrochemical realkalization technique is the best suitable for carbonated concrete system. Why? Any ideas you can guess?
Car Carbonated concrete goes toward its pH reduces, na, ma'am,
Yeah.
less than 9 or 8. Then the carbonated by phenolphthalein we are doing the test.
Hmm.
So we have to alkaline it. That's why by realkalization, from acid to alkalization we have to do it.
Yeah, correct answer. So in carbonated concrete system, our pH is already 9 to 10. So if we are doing realkalization, so we are increasing our pH to again to 13 to 14. So that's why we can say that for if we go for other systems like if we are going to other system like uh, chloride extraction or SACP, ICCP. So in that case, we are saying that in chloride extraction, our pH is increasing near the rebar surface, but that is a very small and it's not even valid for all cases. It's mostly like depend on your electrolyte. If you are using like calcium hydroxide, if we are using, then we can say yeah, our rebar is being realkalized. But when we go for carbonated system, our complete concrete have a pH lower than 10 or 9. So in that kind of system, electrochemical realkalization will be the best technique. The pH of complete cover concrete is increased. In our chloride extraction, pH of only near the rebar was increasing. But in this case, complete cover concrete pH will be increased. So next time, whenever our any carbonation is taking place, so it will take a longer time as compared to any other method. Okay. Last question for today. Match the following: different protective methods: SSCP, sacrificial iron cathodic protection; ICCP, impressed current cathodic protection; electrochemical chloride extraction; and electrochemical realkalization. This is wrong. So, what do you think, SSCP system? What matches it the best?
No need for external applied current.
Correct. For ICCP,
Suitable only for partially carbonated concrete.
no,
Can
can be used in highly resistive environment. Correct. Electrochemical chloride extraction.
A option, ma'am, suitable only for partially carbonated
See, last question only we read that if our concrete is carbonated, then we are using realkalization. Okay. And for chloride extraction, if we are using in chloride extraction, what we are doing, we are extracting chlorides. So mostly from surface, it is easy to extract the chlorides. But when we have to extract the chlorides from below the rebar surface or near the rebar surface, what we are doing, we are increasing our current density. So because of increasing current density, our steel binder bond can be weaker. So that is electrochemical chloride extraction.
ma'am. It means that
देखो
Yeah.
ये
it
हुआ
is
है
good for
ऊपर से कुछ कर
mother
दिए
concrete. It help in mother concrete only, ma'am. Right, ma'am? It's a good
Which method?
ECE method.
EC method.
ECE method.
Hmm.
It's good for extracting the chloride content from mother concrete only,
Yeah.
not from.
If we
Okay,
apply
ma'am.
EC method for a
Great to know.
longer time, it will weaken our concrete.
It means if the concrete has gone wrong, then we have to spell out the spelled part. We have to cover concrete. We have to remove it.
Remove
Then
it.
we can use ECE method, and again we can do the repair work over it.
Yeah.
Yes, ma'am.
That's why these methods are not preferred much. EC, ERA, because if we, for any method, if we increase the current density, there are chances that our bond between concrete and steel will be weakened. Because if you are increasing the current density over the steel surface, that what we'll say, the microstructure will change and it can cause different hydrogen embrittlement can happen if we are increasing current density. Because of hydrogen embrittlement, the steel and binder bond will be weaker.
Yes, ma'am.
Okay,
Yeah, ma'am. Thank you very much, ma'am.
so that's all for today. If you guys have any doubt, please let me know. Anything regarding assignments or something today's session.
Okay, ma'am. Thank you very much, ma'am.
Okay, thank you. Anybody else who have any doubt?
No, ma'am.
Nobody has any doubt, then we will close the session for today and we'll meet next week. Okay, bye.
Okay, bye, ma'am.